Today we will be here working Hess's Law with this example problem. We have this equation which we're trying to find the delta H of, but we don't know what these compounds mean. So Hess's Law is where you can use other equations that have these same compounds in them to get the delta H. So here is our wonderful starting equation, okay? So let's look at the first thing, or the first problem, which is this one right here. This is number 1, this is number 2, this is number 3. So then these two work right here because they have the same number of moles, C2H4, C2H4. There's no exponent that makes it different, and they're both in the reactor side. So this is on the left side, this is on the left side, that's the reactor side. So this one gets a nice big check mark because it's all set. Everything works. Okay, the second one, we have our needed compound right here, but for this one, this one's in the product side, while this one in the second equation, it's in the reactor side. So we'll leave that there for now and just move on to our third equation, and we'll come back to this. So in our third equation, the needed compound is hydrogen gas, which works out because they're both in the reactor side, and the number of moles, H2, were set. So this gets another nice big check mark. Cool. So for this one, to get this into the product side, you're going to need to flip them. So when you write it out, it's going to be 2CO2 gas plus 3 water molecules, which yields our this side now. So it's our C2H6, and 3.5 molecules of O2 gas. So, but for this, the delta H, it flips from a negative to a positive, because whenever you flip it, it's going to go to the opposite sign. So now it's positive 1,560 kilojoules. So this equation can be crossed out because it's no longer important, because this is our good equation now. Good equation. Yay! So next thing you gotta do, since all these equations are good and have everything in their proper place, you gotta write them all together. So you add together all of the reactants that are good and all of the products that are good. You don't use this one because it's not good, it's bad. So that would mean, you have C2H4 plus 3O2, which this is not a 30, this is an O2. FYI, people. Okay, so then we have our new products for equation 2. 2 molecules of carbon dioxide gas and 3 molecules of H2O. That is water for you unknowing peoples. And then we have hydrogen gas from our third equation and 1.5 molecules of O2 gas, which then you would add up all your yield, or not your yields. Yeah, well, technically, this is the yield sign, so it is their yields, but products is what they're called. You add up all of your lovely products, 2CO2 plus 2H2O plus our new products, which is, you saw nothing, plus this from here, and then our lovely other water molecule. So now you gotta cross everything out that equals each other. So we have 2 molecules of CO2, those are crossed out. We have we have 3 molecules. Here's the last molecule of water mixed plus this molecule of water, which equals 3. So that's 3. There's a plus sign here. We have half a molecule of O2 crossed out, so now there's only 3 O2s on this side. But look, here's that other 3O2. So all the oxygens are crossed out, and we are just left with C2H4 plus hydrogen gas. So this gas plus this gas, which then yields our compound of C2H6, which is also a gas. And oh my gosh, look, this is our first equation just like this one is. Hey! But since we added up all of these equations, you also got to add up all their delta H's, which when we get our handy dandy calculator out, you get your math skills going and you type in the numbers.
It's like you click on this top part, and then you just
6, 0, and then negative 2, 8, 5.8, and you enter, and you get the delta H of this equation to equal negative 136.8 kilojoules. To-doodles! And that is a demonstration of how Hess's law works.